Hi everyone. In this video, I will provide you the solution to for the third question of the midterm exam that we had. So what we need to do here is to draw the root locus for this system, which is provided for us as the transfer function with GP equal to s plus 1 to the power of 4 over s to the power of 3 times s plus 2 to the power of 2. And we need to draw the root locus for this system and then discuss the stability. So let's see how we can do it. We have GP equal to s plus 1 to the power of 4 over s to the power of 3 times s to the power of 2, s plus 2 to the power of 2. So we have 4 zeros in this system and 5 poles. As a result, n is equal to 5, m is equal to 4, and n minus m, which is r, is equal to 1. So we have one asymptote, for which we can find out xa and the angle of the asymptote. Xa is equal to sum of zi's minus sum of pi's over n minus m, which is 1 here. For sum of zi's, we have 4 times 1, minus for sum of the pi's, we have 3 times 0, plus 2 times 2, which will result in 0. For the angle of the asymptote, we have 2h plus 1 times pi for the positive locus and 2h pi for the negative locus. And here, since we have only one asymptote, h could be set to 0. And therefore, we will have Kca equal to pi for the positive locus and 0 for the negative locus. And we have xa equal to 0, as you already know. So now we can start to prepare graphs for the negative locus and for the positive locus. I will use the red color to draw the axis, real axis, imaginary axis. We have 3 poles at the origin, 4 zeros at minus 2, and 2 poles at minus 1 and 2 poles at minus 2. So we have 2 poles, 4 zeros, and 3 poles here. This will be for the positive locus, and for the negative locus we will have a similar graph where we have again 3 poles at the origin, 4 zeros at minus 1, and 2 poles at minus 2. Now we can draw the asymptote. We will start from 0, go towards infinity with the angle of pi for positive locus. So as a result, this will be the asymptote for the positive locus. For negative locus, starting from 0, going towards infinity with the angle of 0. So this will be the asymptote for the negative locus. Now we can talk about the sections of real axis belonging to each one of them. We have different segments here from minus infinity till minus 2, from minus 2 till minus 1, from minus 1 till 0, and from 0 till plus infinity. Let's count the number of poles and zeros on the right hand side of each section. From 0 to plus infinity, there is nothing, so we have 0. From minus 1 to 0, we have 3 poles at the origin on the right hand side. From minus 2 to minus 1, we have 3 poles and 4 zeros. We have 7 in total. And from minus infinity to minus 2, we have all the poles and zeros, which will result in 9. So looking at these numbers, we see that these 3 are odd, so they belong to the positive locus, and this one belongs to the negative locus. And we can start to show, to determine the region on the graph. So this is the section of real axis belonging to the positive locus, and this is the section belonging to the negative locus. Okay, so we need to go to the next part of drawing the root locus. Let's see if we have break in or break away points. we have n of s given as s plus 1 to the power of 4 and d of s given as s to the power of 3 times s plus 2 squared. So from here we will have m prime equal to 4 times s plus 1 to the power of 3 and d prime equal to 3s squared times s plus 2 squared plus 2s plus 2 times s to the power of 3. We need to form m prime d minus t prime n and set it equal to 0. So we have m prime 4 times s plus 1 to the power of 3 times d s to the power of 3s plus 2 squared minus d prime 3s squared times s plus 2 squared plus 2 times s plus 2 s to the power of 3 times n, which is s plus 1 to the power of 4 equal to 0. So one way is to do all the multiplications and additions and end up with a polynomial of order 3 of order 8 here, I assume, or maybe even more. Yeah, order 8 we will have here, and then it would be impossible to solve it. Another way is to factor some terms out and then make it simpler. So if you look here, we have s plus 1 to the power of 3 here and s plus 1 to the power of 3 times s plus 1 over there. So we can keep s plus 1 to the power of 3 outside. We have s squared here, s squared we could have there, and s squared here, so we can keep it out as well, s squared. In terms of s plus 2, we have one factor here, here, and here, so we can keep s plus 2 out as well. And then let's see what is left here. We will have 4 times s plus 1 times s times s plus 2. Oh, no, we don't have s plus 1 anymore because we have the power of 3 here, okay? So this is not there. We have 4 times s plus 2 minus, what do we have here? s2 is out. We will have s plus 2, 3 as well. So 3 times s plus 2 will remain, plus 2 s plus 2 is out already, and s squared is out, so the plus 2s will remain here inside, times s plus 1 equal to 0. So looking here, we have s plus 1 to the power of 3 equal to 0. So s equal to minus 1 will appear 3 times. S to the s squared equals 0, s equal to 0 will appear 2 times, and s equal to minus 2. These are the roots of the m prime d minus d prime n equal to 0. And we have this term here as well. Let's see what is the root that we get for this term inside the bracket. We have 4s times s plus 2, so we have 4s squared plus 8s minus, what do we have here? In the bracket here we have 3s plus 6 plus 2s, so 5s plus 6 times s plus 1. We will have 5s squared plus 5s plus 6s plus 11s plus 6 equal to 0. 4s squared minus 5s squared, we will have minus s squared. 8s minus 11s, we will have minus 3s minus 6 equal to 0. Or s squared plus 3s plus 6 equal to 0. The roots for this second order polynomial could be obtained as minus 3 plus minus square root of 9 minus 4 times 624 over 2, and we see that this polynomial doesn't have any real roots, so we don't have no real root. As a result, we have only these roots as the break-in or breakaway point. So we will have alpha departure for the pole at -2 equal to, dividing everything by 2, you have 2 pi over 2 or pi, 4 pi over 2 or 2 pi for the positive locus, pi plus 0, which will be pi divided by 2 pi over 2, and 3 pi over 2 for the negative locus. So this is what we have for the departure angle. Now we just need to find out the angle of arrival, q times beta arrival. We know that it's equal to minus sum of phi i's plus sum of theta i's plus 2h plus 1 times pi for the positive locus, and the same thing plus 2h pi for the negative locus. We have all the zeros at -1. We have 4 zeros indeed over there, so q is equal to 4. And let's see what do we have for the phi i's and theta i's. So let's draw it again here. We have 3 poles here, 4 zeros here, and 2 poles here at -2. Since all of the zeros are here, we don't have any phi I, any other zero, except the ones that we have here. So we just need to care about theta i's. To find the angle of poles which are at the origin with this test point, we draw a line and then draw a line towards plus infinity, find the angle here which is equal to pi. So we have theta 1 equal to theta 2 equal to theta 3 equal to pi. And to find the angles that come from these poles here, we draw a line from them to the test point at -2, and we draw another line towards plus infinity, and you can see that the angle here is equal to 0. So theta 3 is equal to theta 4 equal to 0. Therefore, we will have 4 times beta arrival equal to 0 plus 3 pi coming from here plus 2h plus 1 times pi for the positive locus, and 0 plus 3 pi plus 2h pi for the negative locus. And since we have q equal to 4, we need to set h equal to 0, 1, and 2, and 3. So 3 values for h we need, 4 values for h we need. Therefore, we have 4 times beta arrival equal to 3 pi plus pi, 4 pi, 3 plus 3 pi, 6 pi, 3 plus 5, 8, and 3 plus 3, h equal to 3, we will have 7, 3 plus 7, 10 pi for the positive locus. And for the negative locus, we have 3 plus 0, so 3, 5, 7, and 9 for the negative locus. Beta arrival will be equal to everything divided by 4, pi, 6 pi over 4, 8 pi over 4, and 10 pi over 4, and 3 pi over 4, 5 pi over 4, 7 pi over 4, and 9 pi over 4 for the negative locus. Indeed, beta arrival could be rewritten as pi, 6 pi over 4 is equal to 3 pi over 2, 8 pi over 4 is 2 pi or 0, and 10 pi over 4 is equal to indeed 2 pi plus pi over 2 or pi over 2. For positive locus, for negative locus, we have 3 pi over 4, 5 pi over 4, 7 pi over 4, and 9 pi over 4 is equal to 2 pi plus pi over 4. So, okay, then we are done with the angles of arrival and angles of departure. Now we can go back to the plots that we had and complete them. Yes, we are here. So you can go back and double check what we have for the angles of departure and arrival. I will start with the positive locus here. We have found departure angle for the poles at the origin. Departure angle for poles at the origin. For the positive locus, we have pi over 3 pi and 5 pi over 3. So this is what we have for pi. This will be, the angle here will be equal to pi over 3, and the angle here will be equal to 4 pi over 3. For the pose at -2, we have angle of departure equal to pi and 2 pi, and that's what we indeed have here, pi and 2 pi over 0. Angle of arrival at the 0 for positive locus, we have 0 pi, pi over 2, and 3 pi over 2. So we have angle of arrival 0 and pi, as we can see here, and for the next two we will have pi over 2 and minus pi over 2. So that's what we have for the positive locus. For negative locus, for the pose at the origin, we have 0, 2 pi over 2, 3, and 4 pi over 3. So 0, again, 0, 2 pi over 3, 4 pi over 3. So this is what we have for the 0. Then 2 pi over 3, 2/3 of pi, and 4 pi over 3. For the pose at the -2, we have pi over 2 and 3 pi over 2. So pi over 2 and 3 pi over 2. And for the angle of arrival at the zeros, we have 3 pi over 4, 5 pi over 4, 7 pi over 4, and pi over 4. So we will have, as I already roughly have drawn, we will have these angles of arrival at the zeros. So this will be what we get for the root locus of the negative values of k. So we are done with that. We just need to determine for which values of k our system is stable. You can see that for positive locus, for k bigger than 0, the closed loop system is stable. So we have stable closed loop. And for k smaller than 0, we have always one port here on the right hand side. So for k equal to 0, we have closed loop system unstable. And this is the conclusion that we have for this question. And then, yeah, we are done with the solution of this problem or question. Okay, so thank you for watching, and see you next.